to day 2. Hope you guys having a good time. Alright, so we're going to go ahead and get started. So today we're going to be covering a number of topics from command line to Git to JavaScript, and maybe even do a little more Bootstrap to just recap some of the stuff we did yesterday. Just a quick note about today. I already see that there's less of you guys here today, and I know that this is probably some stuff that maybe some of you already know. But that obviously makes sense. This is still like kind of the basics of web development. But I promise you it's going to ramp up soon. So if you're feeling like it's like a little slow today, or you're feeling like, oh, I already know all this stuff, I promise you tomorrow we're going to start diving into Node and then into backend, into databases, and that's probably stuff that most people don't know unless you actually just know web development. So then, well, so yeah, bear with us. Also today, we're going to be doing JavaScript in a bit. I'll talk a little bit more about that, but basically that might be very difficult for some people and very easy for others. And well, I'll talk about that more when we get there. But yeah, today let's start off with command line and Git. Can I just get a raise of hand? Has anyone, like, who here has used their command line? Raise your hand. All right, okay, well, we'll probably breeze through a lot of this pretty fast. Who here has used Git before? Wow, you guys are just like on off things. All right, well, we will go through this. Basically throughout today, will be checking in with you guys to see if you guys are understanding things. If most of you are understanding it, then I'll probably like go a little faster. If not as many of you guys are understanding it, I'll go a little slower. I got some great feedback yesterday from the forums, so thank you everyone who filled it out. I'll definitely be like using some of that today. And then, yeah, let's get started. So command line, there's multiple names for this. In some places it's called terminal, like I think on Mac. On Windows it's called command prompt. What's it called on Linux? Is it also called terminal? Terminal, whatever. But yeah, so basically what is the command line? It's basically command line interface is actually what it's called. And it's an interface for your computer. Because, of course, back when we didn't have nice graphical interfaces to like open files and click on nice apps on your phone or your computer, the only way you interact with the computer is through a command line, which is basically just a text input. You type things in, you click enter, and then the computer says things back to you. All right? And so what we're going to do is basically just do a quick rush of a few commands that you can enter in your command line. And hopefully, if you guys already know it, it'll be easy. If you guys don't know it, it still should be easy. It's just basically a few words that you want to learn to use in the command line. Before we move ahead, note that for Windows users, commands and command prompt are different than basically everyone else, because Windows. But that's not a bad thing. I'm a Windows developer, and I see a lot of Macs out there, actually. Nice. But it's totally okay because I'm going to teach you guys about a tool called Git Bash, which basically lets you do all of the Linux and Mac OS X commands on Windows as well. Okay? So actually, hopefully everyone should have Git installed by today. So for those of you on Windows, can you just quickly just go into your search bar and type Git Bash, and hopefully you can find this little program. And if you click enter, it should open up. Okay, it should look something like this. Okay? If you're on Windows and you can't find this, raise your hand and some staff will help you find it. Wow, nice. Okay, we're good. Alright, so that's great. I'm glad everyone has that all set up. And basically, for those of you following along on Windows, I highly recommend using that. You can use command prompt if you want, but your commands will be different. And at the end of this little section, I'm going to start teaching you guys the Linux and Mac commands. And when we get to the end, I'll show you all the equivalent commands in Windows. So yeah, this is kind of what a command prompt looks like, or a command line looks like. So first of all, it's like kind of starts as a blank slate. You can see that the first thing is that you have like what looks like a line where you can enter some text. That is the command line. And you can type things in there. So if you have the Git Bash or your terminal open, you can do this. Okay? And so here's the first command we're going to learn about. It's called pwd. It stands for print working directory. And basically all you do is type pwd and then click enter, and it'll tell you where you are in your file system. So if you notice, it says /home/ashish. And that's basically like whenever you open up your terminal, you get basically wherever your user directory usually is, okay? Ashish is not me, it's a previous person. I didn't change the slides. So. There's a few others, and I would recommend like kind of just typing along these if you've never done this before, just so you can get used to them. There's one called mkdir, or make directory. And how that works is you type that in, then you click space, and then you type in the name of the directory you want to make. This is essentially the same as going into your file explorer, right-clicking, clicking new folder or something like that, and this is exactly the same thing. Because again, before you had a graphical interface, like you just had this, and basically all the graphical interface does is just make equivalent visual, clickable ways of doing things that you can do here. So yeah, you made this directory called my app. It should be now in this folder called Ashish. And then you have this command called cd, which stands for change directory. This is also a really important command, and basically that lets you switch into a folder inside the current folder you're in. So if you cd into my app, you can see a few things. First of all, once you print the working directory you're in, it says now you're in home/ashish/my app. But not just that, the little like arrow thing that shows where you are says that you're now at tilde/my app. And so that's an important concept here, that tilde usually is like a shortcut for your home directory, in which this case is home/ashish. And you can always kind of navigate to tilde, so you can like do cd tilde and it'll take you back to tilde. And you can get to folders relative to your home directory by using tilde as a shortcut. Okay, so now we're inside this folder. You can see that this folder also exists on the file explorer. This is actually in Linux, I believe, so, on Ubuntu. So yeah, so now that we've done that, let's move forward. So we're in this folder. Maybe we want to create a file, okay? And you can use this by using this command called touch. If you type touch and then put any file name you want, that will now create an empty file with that file name. So now we have a file called myfile.js, and that exists in the folder. Another really useful command is called ls. This is actually like kind of hard to explain why it's called ls. I think it stands for list segments. But basically, it just shows you all the files that exist in this folder that you're in. So ls shows you now that you have one file in this folder called myfile.js. There's a command called move, or mv, and this is kind of weird because move does a couple things actually. It moves things, but it can also rename files. Essentially what you're doing here is you're moving the contents of myfile.js into a file called abc. And it's essentially the same as renaming the file. And so you can see here that when you now ls after that and show the files in the folder, you no longer have myfile.js, you just have abc. Okay. Does that make sense, everyone? You can also actually move files. Let's say you want to move it to some other folder, you'd say move myfile.js, and then like if you have a subfolder called my subfolder, you do move myfile.js subfolder/myfile.js. And you can see like you're like giving the full path of where you want to move it. There's also a command called cp, which stands for copy. You're copying the contents of the file abc into a new file called xyz. And now if you ls, you can see that you have two files, abc and xyz. Okay. And then finally, there's the delete command, which is called rm, or remove. And you can just name files after it. And if you said rm abc space xyz, you can now see that there are no more files in this folder. And actually, when you type ls, it just doesn't print anything because there's nothing in it. So yeah, finally, so once again, we're in this working directory called home/ashish/myapp. In order to navigate to the folder, your parent folder, essentially where this folder exists, there's a shortcut called ..., which lets you basically navigate to one folder above you. In general, when you're talking about folders and file systems, dot stands for the folder you're currently in, and .. stands for the folder that is above you, or your parent folder. So if you cd to the .. you see that you're now in home/ashish. And then there's another, obviously, equivalent function for removing directories, rmdir. And then you can delete the directory, and then if you try switching into that directory, it says there is no such file or directory, my app. Cool? So yeah, that's basically just a quick rundown of a bunch of things in terminal, command line, and so you can see on the left hand we have all the commands in OS X and Ubuntu and Linux. On the right should be the equivalent commands in Windows. Does anyone have any questions about that? No? By the way, remember that if you have questions and you're too nervous to ask, you can just ask on weblab.to anonymously/questions. Cool. Oh, 2. Oh yeah, weblab.to. Yeah, it's like you're pointing to something. That's yeah. Okay. Yeah. So if we're all good with that, then we're gonna move ahead onwards to Git. Okay. So Git is a version control system, and again, I saw a lot of you have like experience with Git. But one thing about Git, and I've met like so many people who like say they can use Git and know how to use Git, but don't actually know how it works. So we're gonna like pretty at a high level kind of understand what is Git doing and how to use it effectively, because this will actually make your life a lot easier when you're running into merge conflicts in your project, or like you don't like something you feel like is forever lost and you can never get it back. Trust me, if you did Git right, nothing is forever lost. You can always delete the repo and clone it again. Best solution. But yeah, so we'll talk a little bit about that. So before we even dive into version control, what does that even mean? Let's tell you a little story. So this is Bob, individual, non-binary, gender neutral. Yeah, Bob. Yeah, this is Bob. Bob has a file, okay? And this is Joan. And Joan sees the file and is like, hey, you got a dope file over there. I want that file. So then Bob's like, okay, here, you can have the file, I'll email it to you. And so now Joan gets the file. She's like, ooh, this is a cool file, what if I edit it? And so now Joan's made some changes to the file, and Joan's like, hey Bob, check this out, and emails the file back. Now Bob gets the file back, he's like, okay, cool, that worked out pretty well, that wasn't that bad. And so you can see this is an easy way to like share files, you just like email them back and forth, and there's not really too much of a difficulty here. But you can start to see how this can get complicated when you're working not on one file, but on code projects, which can have not just like a document, but first of all, it's code, so it's a little more complicated. But not just that, it's like lots of files. And then you have all these files, and Joan has all these files, and all of a sudden it's like really, really confusing. Like, what do you do with all these files? How do you actually keep track of all these changes? So there's a lot of things that can go wrong. So we're gonna talk about a few of these problems. So first, synchronization of files, right? Essentially, Bob has a bunch of files. He finds a bug in line 3 of some file. He changes the file. But Joan doesn't know that. Joan has no way of checking whether she has the most up-to-date files. So she just goes ahead and submits, and she just submitted a buggy website. That's no fun. So that's kind of sad, you know? That's not an easy solution. There's no easy solution for that. Well, there is. It's called Git, but we're going to get to that in a minute. So, second of all, collaboration of files. You know, we have all these files, and maybe you want to work on the same files. Like, how do you do that in real time? No, you do not code in Google Docs. That's a terrible idea. There are online collaborative code editors, but we don't need to talk about that right now. So yeah, let's say that Bob finds a bug, and Joan thinks the formatting is ugly, so they both change some files, but like now their code is a little different, and they're thinking, okay, how do we actually like resolve this? Because Bob can send over some files, and Joan's like, hey, this is different from my file. You can send over these files, and there's no easy way to fix this. So Bob says, hey, can you like just re-edit my file with the 50 changes that you made to your file and just like do it all over again? And now Joan is sad, you know? So that's no fun either. Basically, yeah, if there's 2 versions of the same file, then both of them fix a different problem, then how do you actually put that together? And finally, version history. Basically, we don't even need Joan for this one. If Bob here has like a bunch of files and decides to change some code, and he goes ahead and removes some lines and adds some new lines to this file. And he goes typing, whatever, that was weird, and changes some other things, and an hour later he realizes that, wait, I needed those lines, right? And now it's like far too late for you to control Z all the way back to where you started, and that's not a really easy thing to do, and without any sort of version control, this is kind of like, you're just stuck, right? The only way to get back to it is remember it from memory and retype it again, and that's no fun either. So yeah. If you break something, can't easily go back to a working copy. And so these are all issues that we have when doing like coding projects, when working in large projects in general. These are things that can go wrong. So how do we solve these? Obviously, Git is a solution, but we're going to actually take a second and try to understand why Git is the way it is. Okay? So before we even look at Git, let's just try and solve them ourselves. Okay? So how about some synchronization of files? Okay? There's a simple solution. Maybe we want to have some cloud thing, because cloud is the future, right? So we're gonna have maybe a server or some machine somewhere, and we're gonna have a timestamp on all of our files. Okay? So let's say I have a file and Aaron has a file, and we both got it at 9 o'clock a.m. Okay? And then I change it at 9:30 a.m. and I'm like, okay. And then the server says, okay, do you have the most up-to-date file? You have the 9 o'clock file? Okay, you can change it. I change it to 9:30. And the server says, okay, now the most up-to-date file is at 9:30. Okay? Then Aaron wants to change the same file on his computer, and so he says to the server, hey, I have the 9 o'clock file. Can I change this file? And the server's like, no, you don't have the 9:30 file. Please take the 9:30 file, then you can change it. Okay? And so you can see this kind of works, right? It basically prevents you from editing an outdated file. And basically, it makes sure that changes are made atomically in some sense, in the sense that every change happens and then another change happens, and they're in some order. They're not actually overlapping ever. Okay? But this has some issues. Obviously, this is a very clear specification. What happens if you're simultaneously changing the same file? How does the cloud even work? I don't even know. This is not an easy solution, right? So we'll see how Git resolves this. Second of all, collaboration or merging of files. How do you actually deal with two files that are different but have important changes in both of them? And the simple solution is make Joan do it every single time. Right? That's a solution. It works, but it's a lot of work. And it's only as trustworthy as that one person who's doing it. Right? But the benefit is that one smart person is probably better than any algorithm we can write to merge files? Question mark. We'll see that Git actually has some algorithms that are really good for merging files, but we'll get to that when we get there. And finally, version history. How do we keep track of past things? How do we get back to previous versions? And the simple solution is just keep a copy every single time you change a file. And this is effective, it works, it's perfect. You can just always go back to any single version just by going back to that version. But yeah, that can take up a lot of space, right? Let's say you have a 1,000-line file, and then every time you add a new line, you save a new 1,000-line file, and then you save a new 1,000-line file. And so that's going to get cluttered real fast. It's going to take up a lot of space on your computer. So that's not very efficient. So yeah, how does Git get around these issues? Okay? So it's time for my take on Git. And that is that Git is basically just tracking changes by doing math. I think this is the most important concept of Git. Okay? Basically, let's say we have a little document here. I'm writing a story, right? And it's really great. Okay? And that's version 1 of the document. And then let's say I add a new line, and I save it, and now I have version 2. Okay? Then from version 2, I add another line, and I add version 3. And so you can see that, in that simple way we talked about version control, we could just save all 3 of these documents and easily go back and forth between any of these versions. But what we want to do instead is try to do some math, which is what Git does. Okay? And basically you can see this and kind of look at the differences between the 2 versions. Okay? So between version 1 and version 2, what did we do? We added a new line called I added a new line, smiley face, at line 3. And between version 2 and version 3, I added another line called and another at line 4. Okay? And so you can see that we now have this kind of log of changes in the file. And what's nice is once we have this log, let's say we lost version 2 and version 3, we can easily get back to them by using this log and only keeping version 1. So version 1, and you use this change log to get back to version 2, and you can use that change log to get back to version 3. And you can see now that we only really need to store one file and this log of changes, and then it automatically does everything we want it to do. And so in Git terminology, we have a few words that I want to talk about because we're going to talk about them a lot. There's something called a repository, which is basically just a set of files to track changes on, also known as your website or your project. There's something called a commit, which is a set of changes in the repository transitioning from one version to the next, which is just the math. So a commit might be like that I added a line here. And then there's a log, which is the set of commits for each version of the repository. So basically the log is all of those commits that shows you how to get from one version to the next. That's also known as the commit history. And so you can see now that what we store is one set of files. Let's say these 3 files are our repository, and then some kind of log for each file so we can go back in time or forward in time for any of those files. And so yeah, now this better Git solution is better because there aren't really any issues. There are some issues, but we're not going to talk about them. Git is amazing. But the benefits is you can really easily revert to any files by undoing commits. You just like do the opposite of what the changelog told you, or you can go forward by applying those commits. And you don't need to store every single version of the file. You just store one file. And you can see how this really works. So imagine if you have a 1,000-line file and you have 10 one-line changes to that file. If you had done this in 10 different commits, then all of a sudden you have 10 1,000-line files that you just save. Whereas in Git, you can just have one 1,000-line file and 10 one-line commits. And that's much less space. So you can see how that really adds up. But what about collaboration, right? We talked about this is just version history, and this is useful for just Bob on their own computer, right? But what happens when Bob needs to share their document with someone else, right? So that's when something called a Git server comes into play. Okay? And basically, we kind of already talked about this a little. A Git server is some computer somewhere on the internet in the magical cloud. Don't worry, we'll be like specifying what this is. This is a web development class. But it'll be some computer somewhere out there that basically is the authoritative figure when it comes to these set of files. Okay? And so they are the ones that say, okay, you change these files, I approve. Or they're the ones that say, hey, someone else should change these files, you should get the newest version of those files. Okay? And so how does this actually work? So let's say Bob has a set of files, okay? And he modifies one of them. Sorry, they modify one of them. And they then make a commit, okay? And that basically says that Bob has basically stated in like pen and paper that, not actually pen and paper, but like in ink, that they are, wow, this is dangerous. They are making a commit and really just like confirming the fact that this is something that they're going to do. Okay? And then they tell the Git server, okay? And the Git server says, okay, you made a change, I'll take it. And that's called a push, okay? And basically, when you push a commit to the Git server, you're saying, hey, Git server, I made a change, please take this. And the Git server will accept it. Now, the Git server knows that it has a new version of the file, and now we have Joan over here with an outdated version of the files. And if Joan ever wants to check whether she has the most up-to-date version of the files, Joan can do something called a pull. And that basically gets the most recent version of the files from the Git server. And immediately, that updates her set of files, and all of a sudden, we have a nice situation where both Bob and Joan have the same set of files. Okay? So again, some terms. Commit is that package set of changes. Push is putting those commits on the Git server, and pull is getting the most updated files from the Git server. Does that make sense to everyone? Cool. So then, what about some merging issues, right? So we talked about this, and now we know how to like have everyone have the same, almost up-to-date set of files. But what about like when two people edit the same files at the same time? So let's say we have a situation where Joan edits the file, makes a push, the Git server gets the updated file, then Bob edits the file, tries to make a push. What happens then? Well, the Git server says, no, you can't do that. Your file is older than the file I have, therefore you need a pull first, okay? So you can see that the Git server, this is an important concept, the Git server is never going to have like conflicts on the server, or it really shouldn't. You can try pushing something to the server, but if yours is outdated, it will be like, I can't deal with this, you deal with this. Just like, no, you can't push this. So instead it says, hey, you pull. So now Bob pulls from the server and gets this new code. And so this is what I mentioned, Git has some magical algorithms that are actually quite good, that basically allow you to merge two files automatically. And you can kind of understand how this works. Like, let's say I made a commit that said I changed this file at line 2, and someone else made a commit that says they changed this file at line 25. Like, those really don't interact with each other that much, and those are pretty easy to put together. And that's just one example, but they have a pretty robust system of putting together files that works pretty well. So, and when that happens, you now get a new merged file. right? And this file basically contains both of the changes from Joan and Bob, and Bob has that on their computer, and then Bob can push that back to the Git server because now this is the newest, most up-to-date version of the file, and now the Git server has the most up-to-date file, right? So basically, that's the solution, right? Just have some algorithms to merge files based on commits. This works because of how we structure these commits. But there's also the fact that like it is an algorithm and it's often not that great and can mess up sometimes. So if you can't automatically merge, you always just fall back to making the puller, the person who pulled from the Git server, manually merge. And what manually merging kind of looks like, and we'll do it today, is just like it says, hey, this is what I have, this is what you have, please fix it, I can't do it automatically. Cool. So yeah, let's try this ourselves, okay? And we're gonna do a fun little exercise together with all of us in this room, hopefully. So, by the way, this is not, the stuff on the slides, which will be posted, basically kind of recaps how you can do this yourself. But we're gonna do this together. So what I'm gonna do right now is I'm going to create a Git repository, okay? And you guys don't need to do this on your own because you can just kind of look at how this works. But let's go to see documents /code/6/148. I'm sorry, I'll make this bigger. Can I make this bigger? Okay. Cool. So by the way, again, changing directory to some directory. You can actually fully specify the directory like I did here. Okay, I can see what I have in here. There's a bunch of Capbook workshops and things like that. I'm going to make a new directory called git test. Okay? cd git test, and you can auto-complete that using tab. Cool. So, right, I'm in this folder called git test. By the way, I'm using git bash because it, once again, allows me to use the Unix commands. But yeah, so I'm in this folder, it's empty. Let's say I want to make this a Git repository, right? Maybe I should make a file first. So I'll touch some file, let's say index.html, okay? Right. And now it should be in there, okay? And by the way, this depends on whether you the way you install VS Code, but one nice thing you can do is you can say code dot, you can try this if you want, I don't know if everyone can do this. But basically, if you set up VS Code correctly, you can write code dot and click enter, and it will open the folder in VS Code, just like that, which is super handy. So you can see we have this file in the folder called index.html, okay? And we're going to leave it empty for now, okay? So now we want to make this and put this on a Git server and say like, hey, this is my GitHub repository, this is my Git repository. So what you can actually do is, I'm going to do this with you guys right now, is you can go to github.com. Hopefully you guys have a GitHub account. If you don't, you should probably make that at some point. You don't need to do that right now, although you might want to. And so yeah, you can create a repository. So let's say I want to create a new repository. Okay, and this is just a personal repository of mine. You say this is git test. Okay? Cool. And I make it public, which basically means anyone can see it. You can give it a description if you want. It's going to create that. Okay? And all of a sudden, already you can see that it gives you some nice helper code. I'm zooming on this. This is the repository, this is the user. It has a bunch of tabs. It's a little complicated, but you can get used to it pretty fast. But basically, it says quick setup. How do you do this? And it says you can create a new repository from the command line right here. So I'm going to skip this. You don't need to worry about this, but I can create it. Basically, how you set up a Git repository is by typing git init. Okay? And it says, hey, now you have an empty Git repository here. Now I'm going to make my first commit. You see I have a file, but nothing knows about that file because I haven't told anyone I made this file. So I'm going to say, first, you can first do something called git status. Okay? And this is a really useful tool. And this says, hey, I'm on this branch, you don't need to worry about that. I'm on my initial commit, I haven't committed to anything yet. And I'm not tracking this file that's in this folder called index.html. So basically, what you want to do is to say, I want to commit this file, you just say that first before you commit it. So you do that by doing something called git add. You say git add index.html, okay? And that basically says, hey, I want to commit this file. Now if you say git status, you can see that that file, it says changes to be committed, and that's this new file, index.html. Okay? And once you have that, you can now actually make the commit, which is saying, hey, I created this file, please record this, so if at any point I want to go back to this version, I can. Okay? So with that, you can say git commit, okay, and then you say -m, and -m is basically saying, okay, this is the commit message. And this is important, you probably want to make this something nice, so that everyone kind of understands what you're committing. So created new index file, right? Okay? And to be fair, by the way, this is something that a lot of people don't understand, but once I've done this, my version history stuff is done. I don't actually need to push this anywhere, tell any server. I can make a bunch of changes to this file by myself on this computer, and it'll be totally okay, because I can go back and forth, because Git just runs locally on my computer. Okay? So you don't actually need a server to do any of that stuff, to basically go back and forth between versions of the file. Okay? But for this case, I want to push this to a server. Okay? So I just follow these commands that they say here. Basically, this says git remote add origin and something. By the way, for those of you guys on Windows and using git bash, you can't control V into a git bash. You can either right click and click paste, or you can do shift insert, which is what I did. I don't know, it's kind of weird. But yeah, this is basically saying, hey Git, this is the server that I want to point to. Okay? So I just did that. And finally, you want to push to that server. So I'll just copy that command and shift insert. So git push -u origin master. Oh, I messed that up. Hold up. By the way, Control C aborts any command that you're doing, because that's useful in command line. So yeah, git push -u origin master, and you see it takes a little bit of time and just boom, pushes it off to this Git server. And if the Git server doesn't accept, it will tell you an error, but it worked for me. So now if I refresh this GitHub repository, you can see no longer that first starting thing, it just has a file in it, and it says index.html. And you can look at the file, it has 0 lines, it's completely empty. Okay. All right, so now we have a GitHub repository, so we got like the fact that, okay, we have this authoritative source of truth. But now we want to share this repository. So what we're going to do is all of you guys are going to get this. And how you're going to do this is I'm going to take this and put this here and say git workshop. Okay, cool. And now you guys can go to weblab.to/git workshop. weblab.to/git-workshop. Okay. You go there, you'll arrive at my repository. Okay. Everyone found that? Everyone wrote that? If you have questions about this, please raise your hand. Staff will help you. Okay. But yeah, so now you should be at my repository. Okay. And we're going to talk about cloning. Okay? And cloning a repository is basically getting the files. Okay? It's basically saying, hey, I want a copy of these files. I want to be a part of this project. Okay? So then you guys, like I showed you earlier, you can go over here and clone it by copying this. Okay? So note that, remember I told some of you guys to download the zip, never do this. You can always from now on clone repositories. So how you do that is you can copy this little piece of text, this button copies it to your clipboard. And then you type git clone, and then that little URL. Okay? Then you click enter, and that should clone it. And I realized I just did a dumb thing, I just cloned it inside my repository, so that's gonna I messed up. Okay, here, let's just move that. Okay, either way, shouldn't matter, it's just there, you can ignore that. But you should clone it somewhere that you can access pretty easily, okay? So hopefully you have this repository now. And actually what I'll do is I'll actually cd out of this, okay, and clone it again here. So I just have another copy of it. And you can have as many copies of it on your computer if you want. And I'm going to put that into git test 2, just so that it's not the same name, because I already have a full copy of test. Okay, so now I have, you can see I just cloned it here. I'm going to go back into my, I'm going to go back into this one. Okay. So hopefully you guys should all be on git test. You should have git test now, and should have a file called index.html. So what I want you guys to do now is go ahead, open up index.html, and you can open that up in a code editor. Okay? and go ahead and write something. So I'm going to write, hi, my name is Rupine, okay? And whatever you guys do, don't write that. Write anything else about that, okay? Just like write your name or something, okay? But yeah, go ahead and write that. And once you've written something in the file, just go ahead and raise your hand. So I know when most people have written something in the file. I suppose not all of you are following along, so that's also okay. So raise your hand if you're not following along. Oh, okay, all right. Either you guys are shy or embarrassed, or it's okay. All right, so hopefully you guys have gotten something into the file. You guys okay over there? All right. If you have any issues or concerns, raise your hand, and you can put your hands down about the other thing. But raise your hand if you need help from staff. Okay. But yeah, so once you have something written in the file, this is the fun part. Okay, so we're going to commit this. So you can go to Git status. Okay, and you see you can ignore this here. I'm just going to delete this real quick. One sec. So yeah, so if you go to Git status in your folder, you should be able to see, hey, you have index.html and it's modified, okay? And once it's modified, let's say you want to make a commit and say, okay, I want to save this change that I made, basically. So you can say git add index.html, and you can again check your status, and it says it's ready to be committed. And git commit-m, and say second commit, or something like that, or you can say modified index, or let's make it more descriptive. Added a hello to index.html. So hopefully everyone can do that. Okay, so hopefully you've all made this commit. And once you've committed that, this is the fun part, okay? So I'm going to go ahead and push this off to my Git server, okay? Yeah, it's going to give me a lot of warnings, but okay. Cool, I pushed it off to the Git server, okay? And now the Git server has an updated version from me, okay? But you all just updated your repository on your computer as well. So what I want you guys to do, this is going to be kind of fun, is I want you guys to just type in git pull and try pull it. And this is when I give everyone in the room a merge conflict, hopefully. It's a fun time. All right. Yeah, right? It's like a plan. All right, so actually I can do this myself, so I'm going to go into, CD test 2. So I have a second copy of it. I'm going to do something similar. I'm going to change this to something else. I'm going to git status, git add, other. So I'm basically doing what you guys did on your machine. Now I'm going to pull from the master, and boom, okay? You can see, this is what hopefully you guys got. This big all caps conflict of like merge conflict in index.html. I can't fix this. I'm Git, I tried, but I can't fix it, okay? And so this is really important, okay? Because this is something that you'll probably run into, and I just want to really quickly show you what you kind of do when this happens, okay? So if you actually now go, so actually let's do a few things. First of all, you can check git status while you're at this, and it will say that you have like diverged, there's a lot of weird words here that sound scary, you both modified, it's unmerged, and even if you're in git bash, it says master merging, okay? You don't need to worry about master yet, I'll talk about that later. But basically it says you're still merging. If this had succeeded, by the way, it would have been totally fine and you would have merged correctly if like you edited different lines. This only happened because we kind of edited the one line in the file, right? And now if you look at the file itself, I'm looking at the other one, I think. This, code index. Yeah, there you go. Okay. So this is the other one. Don't worry about that. So if you look at the file in and open it up in VS Code or your code editor, VS Code actually does a lot of nice things to like highlight what changed and things like that. But the idea is it shows you two things. It shows you head. it says head, and it has like arrows and like equal signs and arrows. Okay? And head is basically what I changed. Okay? It shows that I've changed this stuff. And then this is the stuff that's incoming from the server. Okay? And that's, as you saw, that's what I pushed off to the server. So hopefully you have something like this. Okay? And basically what Git is saying is, I don't know how to fix this, please fix this yourself. Okay? And how you fix this is you go through this following process. You decide what you want to check. You have to do it manually, basically. You decide what you want to keep. So let's say I want to keep whatever they wrote. Okay? So I'm going to get rid of everything else. And I think I like what is on master, but I also want to add some of this at the end. Okay? So that's basically my intended effect. Okay? And then now that you've made this change, you can go back here and be like, okay, I've modified it, I'm happy with it. You add the file. Okay. Git status, and now it says changes to be committed because you added it. You make a new commit saying fix the merge conflict. Okay. And now your GitHub repository is all set. And if you were me, you would type git push. Okay. And now on the repository online, you can see, yeah, it's there. By the way, you can try and push, but you don't actually have write access to this repository, so it'll just reject it. Okay? So that's something when you set up your repository, you want to make sure that you share it with everyone in your team. You can do that in collaborators over here. I don't want to do that right now. But yeah, so now it's here, all the stuff is fixed, and if you actually can go into the commit history to see what's been changing, and you see, I created a new index file, I added a hello to index.html, okay? This is basically what you guys did, essentially on your computer, this other commit, and then to fix the merging of these two, there was a final commit that said fix the merge conflict, okay? And you can see we have an in-depth history of all the changes that we did. And you can easily go back to any of these, and click on them and see what was there at the time. Okay? And that's basically a quick high-level overview of GitHub, okay? And Git and how you use it. Okay? I know this can be a little confusing, so don't worry. In the slides, we have a bunch of examples in code and on GitHub and things like that. But just to wrap this up, just a little recap. Remember, to create a local repository, use git init, and then you make a commit. To set the server address for a local repository, you do git remote add origin and then the link. Don't worry that every time you create a GitHub repository, you'll find that. To send changes, you push. To get updated files, you pull. And there's some useful commands called git status, git log. I didn't actually talk about that one, but you can find that in the slides. All right, so hopefully that's everything for this. If you guys ever have issues with Git, feel free to post on Piazza, come to office hours. I'm sure this will be something that we've seen every single year that people struggle with. So I hope this was helpful, and next up we'll be going into some JavaScript where you guys can take a quick 5-minute break.